Hello, this is Streamer and welcome to Genius Mathematics. In this video, we will be seeing an episode of Let's Solve. In this episode of Let's Solve, we will have a question which involves the HCF, or it involves to find the HCF of numbers. Here we have what is the greatest number which divides 852, 1065 and 1491 exactly, which means we have to find the greatest number which is a factor of all these numbers. So there are two methods as we saw in my previous video. One is the one is to find by using Euclid's division lemma, and the another thing by prime factorization. First we will use Euclid's division lemma to find the HCF of these three numbers. So the formula is A equals BQ plus R. So first we can take any two numbers from these. I will take these two numbers because these are higher numbers. So have the highest number for the value of A and the lower number here times the quotient plus remainder. So this, if we divide this with this, we will have quotient 1 and the remainder we will find out just by subtracting these two numbers. So we got 426. So this is the remainder we got. Now take this as A and take this as B. So 1065 equals 426 times plus some remainder. So what we will do is multiply 426 to the nearest number of this. So 426 times 2 gives 12, 5 and 8. So we got 852. So 426 times 2. So what we need to do next is 1065 and 852. We need to subtract this. So we get 213. So that is the remainder. Again take this as A and take this as B. So 426 equals 213 times plus remainder. So if we multiply 213 times 2, we get 426. So and we got remainder 0. So as we got remainder 0, the HCF of these two numbers we took at the beginning is 213. So the HCF of 1065 and 1491 is 213. This is the HCF we got here. Now the next step is we need to find the HCF of this number and this number. So again do the same thing. 852 equals, so this is the number A because this is higher and this is number B. Quotient plus remainder. We will do 213 times 4. We will get 852 here. So 4 and 0. So as we got 0 here, the HCF of these two numbers is this. So from Euclid's division lemma, we found the solution for this question as 213. So by using Euclid's division lemma, we found out the answer for this question as 230. Now let's use the next method, that is prime factorization. We'll first do this for 852. So prime factorization means factoring by only using the prime numbers. So if we do that, we get 426. Again doing this will give 213. Dividing this by 3 will give 71. So 71 is a prime number, so we have to stop it here. So 852 equals 2 times 2 times 3 times 71. So the next number we will have is 1065. Doing the same thing, we cannot do 2 here, so we will have 3. So 3, 5, 5 is the number we have. Again doing this with 5, we will have 71. Again 71 is a prime number, so we will stop it. So we have 3 times 5 times 71. So the next number is the last one, that is 1491. doing the same thing as prime factorization, we'll do with 3. So we get 4, 9 and 7. So this is the number we got. Again doing this with, we'll do this with 7 because this comes in 7 table. So 71. So we have to stop it there since we got a prime number. So 1495 equals 3 times 7 times 71. So this, now we will get to the last step, that is for finding HCF we need to find the common terms. We can clearly see the common terms are 71. But is there any other common term? That is 3. 3 is another common term that is seen in all 3. We should not take common terms if it is just between two terms. You need to see all the 3 terms for a common term. So here the common terms are 3 and 71. So if we multiply both these, we will have 213 as the answer, which is the HCF of these two numbers. This is same as we got from using Euclid's division lemma. So from this also we got 213 as the HCF. So from this we can conclude that the answer for this question, that is the greatest number which divides 852, 1065 and 1491 exactly, is 230. So that is the answer for this question. Thank you.